Hello, and welcome to another video where we are looking at the old Spiderman bits decompressed. I need to go to a thing. How do I get a go to? What was I looking at? I was looking at. Do we not? Do we not do it? Can we view entry point? I think is it called this? Um, because it kind of just started me at this entry, but there's another thing. How do we see all of the things that um or like functions will probably do it? Yeah, and like one of these, I mean, this function will do the trick. So this was coming through this, and I kind of talked through it, and I don't know, it was hard to describe things. So what I've got is, if we maybe make that smaller, maybe a little big. I just want that much, maybe. So I've been going through these bits and working out what spikes are doing, and I've kind of gone through all this code manually and this midnight decoded stuff. So I'm kind of going through step by step. Maybe I'm merging some steps just to make it a bit less verbose, but I've kind of got up to the point where the first time through, it gets this number. So this is, maybe I'll go like this, and we can make that a little bigger. So first off, I get this number here. This says 2. This is basically the number of times I'm going to do a loop, and I'm about to do a loop. Gosh, what a loop it will be. This byte here was saying this is an index into a table, which I'll describe in a second. And this one I can't recall off the top of my head. But yeah, this one, it just happens to be 0, but we'll get to what it actually does in a sec. So we get a byte. We actually read 2 bytes, so there's 2F and A8. And we apply some mask to it. So if I get this 2F A8, and I mask it with 1F, and maybe do a hex on that, because and it is now being hexed, and it is OF08. And what that is kind of describing is this point here, this 69. And the other bits that it doesn't really talk about is 60AO, I think it was. Is that right? Doesn't really matter, but well, it kind of does. Well, it's in the source. One can always look at the source to be 60EO. So it gets that, and it gets 2080. And this is kind of describing the, if I get this right, yeah, and then we like shift right by 5. So we get all of this, and maybe we do this and shift right by 5. And yeah, so that is getting kind of sized. So this is 1 and 5, and it offsets both of those numbers by 1. And so these numbers are kind of treated, they're 2 bytes, and each byte is X and a Y, and then the next 2 bytes, well, in the same 2 bytes are the width and the height of a box type thing. And it kind of describes this there. Imagine that it doesn't kind of go over there, but just kind of these 2 lines, and it gets each of these tiles and it puts it into a chunk of memory. And beforehand, it writes like a bunch of stuff to say where it's reading from and stuff like that. So it's kind of setting up a structure of types. And then it gets to this next one, which is 8, 7, and 7A. And importantly, the 8 is set. And in this source code here, we have a test whether the 0, basically the highest bit, is set. And in this case, it is set, so it is not 0. So it will fall through, and it calls this weird wacky function, which I'm now trying to work through. And to start, I did some things where, we're reading from BX, and I recall we set BX to, well, say that here, it's BX is 150 plus 3 times that thing. So basically, this BX and BX1 is reading from somewhere, and in this whole loop, we increment BX by 3 each time. So it's kind of interesting. We're going down a different track. And so if I look at these 2 bytes, and so we'll get this first mask, and we get the 2 bytes, 8, 7, 7A, something like that, and then we get 7 and 1A. And you can kind of see the 7 is less than the F, and the 1A is higher than the 8. So in this kind of thing, when we're talking about this point here, you can kind of imagine that it's going to be a different point. And the point it is actually talking about is this point here, which I believe is where R2D2 little fella is. If we go play, and this will spin us up a thing. Takes a little bit of thinking, just a little bit of thinking. Gosh, it's got to like load up all those 16-bit codes. Nah, I am like pumping my machine like power, because that's what it is. So this is the game, and so I was describing this thing here, which kind of interestingly, this one is included. So we're standing on 1 tile, and how many have we got? 1, 2, 3, 4, 5, 6, and it's like 2 tiles tall. So it's copying all of this, which is interesting because it needs to know how to do stuff like this. So there'll be some code in there that when I stand on this point, so before it was describing the entire object, but it wasn't talking about this particular point. So I guess that's not a switch per se, but it is a moving object. So this loop is kind of getting the moving object, and this guy here, like, he would have started roughly where it was. So in terms of switches, this level does actually have a few switches. It's got one there. It's also got one we can how do we do this? I can kill myself. I just want to do that. Well, no, not really. There's also a switch there and a switch there, but you can also hit this switch, and it's hard to do. What I tend to do is, gosh, is this guy gonna like? No, we can actually just do that. What? Yeah. So what I want to do is try and find those two things. So these bytes are kind of going to tell us that in terms of the first one, yeah, so that guy started there, but he was pointing that way. In terms of hitting that other switch, what we can do is oh, I copied the original. All right, we could do some hacks that I'm not really keen to do while it's lagging. I had a test run, which I suppose I could do a patch tile. It does a lot of stuff. Apologies for your screen going all that blurry and whatnot, but what it is doing is I think it's like making some space, but it's also then kind of clearing out. In fact, like maybe if I do that, it's at the moment clearing out each of these tiles, but it's doing it like one by one because the program's kind of interesting there. The program is kind of so now if we do play, we'll have a room that we can kind of go to and perhaps hit the top switch. Gosh, we just got to load up everything. Yeah, it's interesting that it had this little thing at the end. I don't know what command I was doing to do it, but yeah, now hopefully if we go this way, I can come up the top here. And if we hit, so I think if I go here, I can jump over. So that's not a switch, and that's not a switch, but this one is. So pretty much the two things were switches. And then, as I said, that one and that one. And there's a switch there, which, golly, I wonder. You can't, well, I suppose once it's switched, I suppose this switch might be actually there. Once it's switched, you can't like re-switch it. I'm just thinking maybe there's like a thing here. But there is not. Cool. Anyhow, haven't really done too much in the way of videoing, but what I thought I might do is kind of just continue off to where I was. So now that I kind of described how things kind of went in kind of layman term, rather than like step by step this, I thought I can now show kind of what things are. That's right, the BX, I didn't really say how I figured out where the BX was. Could be useful for people interested in G-Hydra. So in the call to this, we know that we set BX to at 1.150. So what we can do is we can do a search for. I was going to say I'm going to sneeze, but as I said it, I was going to sneeze. We can search for the hex this, and we can see there are two things that are doing it. Maybe more of interest, kind of moving things to there. And so we do have something here. This is moving a bunch of stuff from 819 to 150, and it's kind of doing that, and we've done that, and it also does some stuff here. And if we see where this is called from, hold on. If we see where this is called from, this is called like up here, and it's called right after we read in runes.spl. But then we read. Yeah, so it's like kind of filling in those parts. But where does it get the stuff? Where does it get the stuff? So here we want to see where 819 comes from. So we can use that same search technique, 819. And if we search for that, there's again two things. There's one that we're looking at and one that is doing this. And this it didn't have a name before, but once I looked up where backs.spl was, which is at this 1D3A when it's unpacked, so that G-Hydra doesn't kind of display that fact. But then down here we can see 1D4E was just a bit after it. I went and searched, and we have movertab.dat. And in movertab.dat, if we close this, so maybe we can, where's everything show up? So if we have a look at, where do I keep it? Movertab.dat, and if we just look at maybe the first two things. So we can see here we have 0, 0, 0. So that's like a thing of 3. And then we have 0, 0, and then B8. And that B8 is what made that R2D2. And we can see that it is shown like a couple more times. And they're kind of spaced every 3 things, but not everyone is used. This has a particular length, and this kind of file, I think, is describing how things are moving and what things are moving. But yeah, so I kind of want to bring that maybe back there and I don't know, do something like that. So I now know kind of where everything came from. It took a bit to work out where the memory was, and I was like, gosh, what writes there? So we have to kind of follow a couple of paths back. And at some point we get to where I was. So as I said, we kind of ran through this and wrote some structures. So this is kind of the current memory as of the point at the bottom of the file where I've kind of gotten up to, well, like in here actually. And I haven't really said what I've consumed, but like I'm kind of stepping through slowly, and it's not like a giant case, and there's not that much happening. And I'm also interested in all the different types of things happening. Like there is a switch that kind of opens something in a different room. There's a switch that opens a platform. There's a switch that raises that. And yeah, there's also a thing that moves back and forth. There's some other, and like once we learn stuff, we can start trying to apply code to it and work through it into the thing. But yeah, so this is kind of just saying this is the first byte. I think that was the first byte. Yeah. Perhaps I could say that. First byte. Perhaps that's so like things can scan through and find it, but so far I haven't seen what is reading it. But we have the first byte, then we have the offset into the map where the helicopter was, and then this is the index into that mover tab, and this one was 000, so it doesn't really matter. And then here's the dimensions of this list. Then we have that many things, 18 things, and this is just all the tiles going kind of in order. And that was kind of one structure. So one loop pass did that. And now we're kind of onto the second loop pass. And we can see here that it kind of starts off similarly. So it takes the first byte. So we could say here, first byte. And then this is a tiles offset. I haven't worked out what, wow, this is a offset to R2D2. I have worked that out. Here is BX, which is, yeah, that index into thing. So maybe I can do that and do this and do that and do that. And here we have, instead of dimensions of the list below, we have another kind of address. And this address is kind of pointing to a different structure, which is this structure here that I'm starting to kind of fill out, where BP is kind of written to various stages. And here it has a different sort of structure, and I haven't really said what the meanings are yet. And I also kind of put through other random parts of memory that are written to at this stage. And here I'm kind of putting what my kind of things are. So maybe this is a number of questions. Heli and R2D2. And this counter is doing a thing. I can't recall what it was doing at the moment. But yeah, so this was the first scan of the loop, and this is the second scan of the loop up until a certain point. And unfortunately, my laptop crashed when I was doing it. I'm fiddling around with keyboards, and yeah. Expensive keyboards, then they break, and then you're like, oh, I don't know what to do. But yeah, what I think is happening is we got to there. So BO equals something and 7. So we get that. And then so this is from mover tab. 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 Something like that, I don't know. Right, so in BP there, and then what do? We do some more things. Now you get to see the joyous view of me just, I don't know, writing assembly. That one. Right, so what do? We're going to double the bottom one, but kind of wrap it around. It might not make a difference. Yeah, so it's set to 0, so this doesn't really do anything, so we can kind of skip over that. BX is now getting added to right, so maybe we would have a temp BX. Do we like we have pushed this. So yeah, maybe we'll just do a temp BX, and just to denote that it's not that. And when you get to a pop, you just know that you can go back. So this can be plus equals A9E3, and I'm not sure I've looked this address up, but what was my last BX? It is kind of pointing to the mover tab. So this is like 153 is what it is, and this should be that. Yeah. Cool. And the bot is still the same. It's just a typo. So this becomes a bigger number. So what do we have? We would have A there. This one would probably change 9 into an A. The 5 in the E would overflow. So say we had E like that. If we go 5, then and we get 13. So this would overflow that and we'll get 13. And then the 3 and the 3 would make 6. Good to just do some mental arithmetic. But what we can do is A9E3 and do like, no, we can't really do that. We could show it up in Python, get a snake out. So 153 plus A9E3 and then X, whatever that was, and AB36 is what we got. Good to practice old mental arithmetic from time to time. Right, so now we have that. We're going to read a byte from it. So CX equals TVX. And what is this value? So AB36, we haven't really written. But what we can do is do that same sort of thing where we search for some things. And if we search for this, we can see there's a couple of things that do. So what are we doing here? This is where we are, surely. This is something else that is not where we are, but it's kind of where we get. So it calls this. Is this one? Yeah. We also have it here, and this is reading from it. So I guess I want to find a point where I'm writing to it. But it seems like each of these times we are simply reading from that address. Now, is this in the middle of VGA memory? Well, it's like we've also got to kind of worry about it's going to be reading from DS, right? Oh, yes. Yeah, I think it's going to be, but then I don't know why this has DS for everything, but I'm pretty sure this will read from DS. So I guess what is DS kind of set to? Does it get set to a thing? Might get set real early on. This was just that place before. Yeah, so VDA memory map. This had a thing in Oh, this did have it at some point. This can go away. This is like just not the memory map that I thought it would be. These are all ports. I'm not doing ports. Um, bunch of things. Like, I'm just wondering whether I am reading from video memory, but that surely is a lot. Like, it's pretty gross if I am. Dress calculations. We've just got a bunch of to-dos. All right, this isn't really that helpful. This is yeah. So we would kind of be in the middle of this, but like in a kind of weird place. But depending on what DS is set to, which I think it does get set to something useful, surely. Perhaps not. So yeah, I'm not too sure where to go from here. This is the problem with assembly. It's like you just get caught in these like weird places where you're reading from a thing that just doesn't make sense. Where is that? I wonder if like even just a search for a 93. It surely isn't like a thing. No, this seems like it. Gosh. Like, is it VGA? I don't know. It seems like it's in the middle of it. And it seems kind of weird. Because I've got kind of nothing after 9600, and I think this has like um a memory map. Yeah, so this is a memory map kind of showing all the places that it kind of expects things to be. And this doesn't have a thing that kind of has that A9. Well, it kind of does here, like this whole thing. All right. And this is kind of what it is. But then else is the pack file. I don't know. That seems it seems weird. I think I need to think on it again and also like take me back to where I was. here. So yeah, yeah, use those. Where is this memory? To need to work out that. Yeah, I know. Um, but yeah, I guess that is like, what would this thing be doing? I don't know. We're just getting this, and then we're subtracting 10 off it and kind of storing it into this. So maybe we can kind of continue on anyway. Don't know what is here. But DO, which, what do we have DO kind of set to? DO is currently this. So we're going to plus equal to CH. So this is going to be like 3 8 plus AB 36. I don't know. That's just what it's going to be. And then we're going to take A off that. Subtract 10. And then we're going to put BP 3 equals DL. So we can kind of see here, maybe if we do, I can do that, and BP, something like that. And so we are setting 3, and so I guess this can be down 1 and down 1, and do that, and so it's going to be something like this. All right. And then what do we do? So we've gone down a bit. So we CH equals 0. So those reading a whole word. So there's 2 bytes there that we did, but we're now clearing the top one. But the first one kind of gets set. So here we are adding CX to AX. So AX was CX. So AX was this, that thing. And now this is going to be plus 0xab37, getting the next byte in. And then we're subtracting A, and then we're BP1 equals AX. So this is going to be 2 things kind of run there. And we have, yeah, we do have that. Cool. So 1 is going to be this. So this is going to be 1. Take 2 off that, and it's not going to be that. It's going to be this whole thing. And this, I think, is just a byte, right? Yeah, this would just be a UH. Because it's kind of only taking that. Yeah. And that's kind of clear. It's just a byte. Cool. So that's kind of got some things. So we don't have 0, but we're about to set 0. So 0 is just going to be 4. Oh, all right. So 0, and this is just 4. And then we AX, we did some. Where did we? So we're popping it here, but where did we push it? We pushed it way before we did that. So I guess this should be temp. That. And then BP 0 equals 0, 4, easy. And then we AX equals so wherever we first get this, so AX was all the way back here. So AX is just the first 2 bytes, 877A. 877A again. First 2 bytes. Is that right? 877A, yeah. Right, and now we're going to get AX. So this is going to be n equals 60 EO. So this is again kind of describing dimensions, I guess. And I wonder if this is describing the dimensions of the actual R2D2 unit. So, gosh, what's this going to equal? So the 8 doesn't really align with the 6, so it would be 0, and the would have 0 there, and then E kind of does have a few bits of 7. I think 7 of them. So I think it would be that, and maybe if we get Python up then to 877A and yeah, sorry, keyboard issues. On a temporary one, and if we do a hex of that, we would get 60. Gosh. Yeah, I suppose E doesn't. Yeah. Cool. So that is describing things again, hopefully. Right, so now we're going to shift right twice. So 2. So shift right that's just dividing by 2, then 4. So dividing by 4. 60. 2, and then it's over this. And so there'll be 1, 8. Right, easy. Now we want to or AL with AH. So we're kind of just getting AL equals both the bits, but this is just going to be that. And then we're going to shift right twice again. Golly, is this just? Golly, no, this was AH is that. So this is just dividing by 4, and it is 0. And then we're getting the original 60. So this is just going to be 60. Easy, it hasn't really changed anything. And then here we're going to shift right twice, so that's going to be divided 4 again, and now this is going to be the 1, 8, and we're basically entering the top. So this basically means that this is the total thing. But we want to times 2 that. Well, maybe I'll do x times 2. So this would get what would have 2, and then this isn't quite right. So 18 times 2 is of that 30. Yeah, that kind of makes sense. And that's just because we're adding it to itself. Cool. Now what do we do? Bx is going to be this A9F3. Hopefully we can figure out what that is. Bx plus equals this AX. And so what do we have here? A9F3 plus 30, and then X of all that. I probably could have done this in my head. AA23. Right, and then we are overriding something. Now the BX we have something. So we're trying to read BX3. All right. So where is BX pointing to? AA23. So start of 0x that. Come on. Back to there. Where is this number called for? So A9F3, we can probably do a search for that. A9F3. We only use it in one place. Golly. So what's this AA23 kind of pointing to? Because we didn't really know this. I don't know. We're starting to run into a few different unknown bytes and things, and I'm just wondering where things kind of get set, and like how do we know what's happening at this point? But yeah, we're kind of writing more on this BP thing. And then we read some more stuff, and then we set more BP. So it's just kind of filling out the rest of this, and we'll have 2 functions to kind of step through. But yeah, I don't know. I think I might stop this here. Get some things from the going before it gets too dark. And yeah, maybe I'll try and work out where these things are. But for now, this is what it is, and I'll see you another time. Thanks for watching though. Let me know what you think, and see ya.